Hi, fellow developers. This is my new series of videos covering Stl.Fusion tutorial. And even though the tutorial itself is, I hope, pretty well written, contains a fair amount of information, but it's text. And I'm basically going to do everything that's listed there, but in video as well. And put the link to all these videos into the tutorial itself, so that basically there will be two forms. And in addition, I'm going to show maybe some parts that are not super clear here. So let's start, and we'll start from very beginning. So this is the repository of Fusion samples, and tutorial is a part of this. To run it locally, you need to clone it by basically copying this text and typing something like let's actually clone it to somewhere here, right? So you will get a copy, but I already have one, so I don't need this one. And I'm just going to proceed. So the next step is to install try.net tool. And by the way, this is the tutorial folder. And to run it, you need a tool. You see that this tool is missing. So to install this tool, you can scroll to the very bottom of this page, click on install try.net, install its preview version. Currently, release version has some bug that prevents it to run at least this tutorial, or maybe something else. I don't know exactly. So I'm installing the tool right now, and once this process completes, I will be able to run this one. So that's the result you should see. It should open this page, and after that, you could, or you should be able to run any code right in the tutorial, right? Like, let's say this piece of code, you can click on this link and you should be able to see the result. But for maybe the sake of clarity, I'm going to create a new console app project, and I'll be using a separate basically project here to show how it works. So let's do this. Let's create a new folder and type .NET new console, right? We have a new console project here. I open it right now. Yeah, probably I run right there twice. Okay, so I'm going to add Fusion to this project right now. And I'll add just its core part. Okay. So the only change that happened is basically we've got this package reference. That's all we need. So I'll be mostly copying code from the part 1 in this video. So and maybe talking about some aspects of what's going on. So let's copy the first piece, right? Import missing references. Okay, then let's copy this part. It's a class, we can put it here, right? Again, import missing references. So for this one, it's a little bit trickier. Okay, and technically we should be able to run this request here. Okay, something like this, right? Okay, yeah, it works, and so let's talk a little bit about what's going on here. First, we create a service provider. It's a regular service provider from, I think, Microsoft. What's the namespace? We got extensions. Well, oh wait, yeah, this interface is from system, but this one is from, yeah, Microsoft extensions, and it's injection, so it's a regular default service provider implementation. This method is, you can also control click on it and see what's going on there, but overall it registers a bunch of services that Fusion needs to implement this thing, compute services basically. And as for this call, so I can control click on it as well, but that's not quite like self explanation. But anyway, so this thing actually finds all the types in the current assembly that has an attribute which is, a descendant of a service attribute base. And service attribute base declares virtual register method, which is invoked by basically this method for all the pairs of this attribute and the service. So it basically allows you to implement a registration logic right in the attribute, and if you click on this method, you will see that basically all it does is it calls services at compute service and then passes either the service type, I mean, so it's like one of properties of the attribute, or the like implementation type if service type was not provided. And lifetime, the default lifetime is singleton. So we can do the same here. You can simply remove this thing and calendar service, and it's going to work the same way. Nothing changes. Okay, so now we are ready to talk about the compute services. What are they? And if you go through the examples here, you will find out that, like, so far here we call a method called, well, let's actually talk about what's going on here. So this service has two methods, right? First one is get async, and it gets a key. And ultimately, you can think of like what we are trying to implement is named counters. We want to have a counter with name or like key that's defined by this parameter. And we want to have two methods. First, we want to get it by calling this method, right? And second, we want to be able to increment it. So each of these methods prints a message to console when it's called, and basically it does the job, right? In addition, the increment method uses a little bit weird construction. Basically, it calls invalidate method on it's a static method on computer class. We can also control click it, which gets a func called producer and like does something. But ultimately, it kind of tries to call get async here, right, with the key that's provided to it. And I'll show you what happens when this method actually runs. But for now, as you see, basically nothing is unusual, right? We see that get async for a is called, then the output is printed here, right? Then, okay, wait. I guess I should post the video right now, and I just understood that my picture is right on the left part. So I'm thinking how to resolve this problem. Okay, so I just came up with a super smart solution. So as you see, get async basically is called and prints that it's called, and the result is printed when this line runs, right? The second happens for basically, sorry, the same happens for the second call, and the result is printed as well. Okay, so nothing unusual so far, right? But what's going to happen if we change this? Well, let's see. And it's interesting because get async was called just once, and although the result was actually produced twice. So what's going on? I think one of good ways to learn what's going on is to run it under debugger. And you will quickly see that the stack trace is not like so straightforward here. And here's the place where we were actually pulling get async, right? But like there is a number of calls, and most importantly, the first call goes to counter service proxy, the type that actually is inherited from your type. I mean, from this one, and in fact, it intercepts this call and does some extra. But ultimately, in the end, it calls get async. So it doesn't do this all the times, and sometimes it doesn't. Let me explain when. If you, I actually recommend reading this part of the tutorial, but basically the behavior you observe is very similar to caching. If Fusion sees, like these compute services, if the proxy sees that the result for a given call is still available and consistent in, you can think of this as a cache, then it will simply reuse it. Basically, it will not call the method and will return the same result without doing the computation. So now let's copy this thing, right? And see what's going to change. I'm stopping the debugger and as you see, I could increment in the middle. So the question is, will the output change? And the right answer is yes. So after the increment, get async is already is actually called again. So clearly this thing, this one, invalidates or like evicts the entry from cache, right? And you can even simply put it here, right? Okay. So you need to pass the same set of arguments here to make sure that the correct entry is invalidated. But overall, it works the same way, just print 0 in this case, because like we didn't do the increment, right? So basically you can think of these compute methods as methods that kind of cache their output. And there is a way to invalidate what's cached. This is the way. So if you think of your like set of services you build as like services that mostly read the data and services that write the data, then the methods like this one that read the data, they basically just do their job and the methods that write the data, like increment, they also have to run invalidate somewhere, or like ideally in the end, to evict the entry from this cache. And for the sake of clarity, cache is actually the whatever is cached is actually cached in process. It's not like living in, I don't know, some external memcached or Redis or something. Okay, so it's actually not stored in external cache like memcached or Redis. Okay, let's move on and let's do a little bit more complex thing. So let's add another service. Right now, I'm actually, let me remove this useless attribute, and since I'm anyway registering these services manually, I'll just add one other line here. So what is counter-sum service? It's a service that uses counter service, right? And it's going to have a single method that produces a sum of two counters with key 1 and key 2. So let's see how it works. And again, I'm going to copy a piece of code from that tutorial. Let me actually leave both counters and counter sum here. So first, we are going to call it twice. Counter sum for the same set of arguments, and see what's the output. Ultimately, the output shows that every method was called just once, even though you see there are two calls. So basically, like if they would behave as normal methods. Oh, by the way, I can actually show you what's going to happen if you run them as normal methods. So we can simply replace these calls to like a singleton, I guess, right? And the same for the second one. And we comment out this one, right? So that's the normal, right? And now, as you see, like in our case, the output was very different. Every of these methods was called just once. Let's swap the arguments and see if there is any difference. Well, so there is a difference, and as you see, it doesn't treat the second call as or like basically, since the order of arguments is important in terms of you can think of this as like these arguments, they compose a key, a caching key, and here is like a brief description of how this key actually looks like. Basically, it includes method info, pointer to the service itself, and all the arguments. So the order is important, and which is why it doesn't think it's the same call as the first one, right? That's why it recomputes basically the value for the second call. Okay, so now I guess you could be curious what's going to happen if we put increment here, right? Let's increment A. Uh, oh, that's a fancy bug. So I created another service collection and basically counter service. I mean, this counter service was from actually another container, which is why the result didn't change. So as you noticed, I just changed this part, right? And as you see, this is a new container. So I put actually what I intended to put here. And basically I use the same service provider now. So let's rerun it. Okay, so now we see an interesting result. Even though we didn't do anything special to invalidate the output of this method, it actually produces the correct result somehow. And so the question is how. And this section kind of briefly explains this, but overall, when this method runs and when it calls other similar methods, I mean methods marked this compute method, they basically the outputs, they enlist themselves as dependencies of the output that is produced right now. Basically, they build a dependency graph right when the computation happens. And this graph is later used during invalidation. So when increment runs, when invalidate here runs, it will invalidate not only this thing, but everything that depends on it. And that's the beauty of this approach. You basically get automatic invalidation of any kind of cached output that is produced. So let me show you a few interesting consequences of this. Just let's just put two A's here, right, and run same method. As you see, getAsync was called once here because like it doesn't make sense to call it, or like basically as I said, the output once it's produced and cached, basically the second call shouldn't even kind of, I mean, it will reuse it. It shouldn't run twice, right? And the same happens after the increment. Basically, this one is re-evaluated and this one is re-evaluated. Okay, now let's actually do another fancy thing to illustrate how it works. So first, this sum async seems to be written in a little bit weird way, right? There are two, like if you look at this one, the like what it does is nearly like this. Then so that's how this method body should look like if we a little bit if we basically introduce variables. But like it's weird, right? Then that we call basically this is an asynchronous task, right? And this is another synchronous task. What prevents us to run them in parallel? Nothing. So let's actually do this, right? So and this seems to be the right way to do this, right? Basically, we start two tasks. Oh, by the way, just for the sake of clarity, because I'm aware about like, sorry, computer weight, and I'm just not using it here because, well, I mean, for the sake of simplicity. So anyway, so we just rewrote the body of this method in such a way that it will try to run these tasks in parallel. Will anything change? Well, nothing, right? And maybe that's because this thing is quite fast. Let's make it kind of much slower. So, but also let's get for when we enter this method and when we exit this method. Let's plus and minus here, and so we wait for 1 second here. So basically we are making get async really slow, like, I mean, or maybe slow enough to kind of show the some interesting properties of these compute services. So let's run it. So as you see, interestingly, even though we created 2 tasks here that are supposed to run simultaneously, get async still runs just once. Let's actually change something to see if like this parallel behavior works, right? So, okay, as you see now, for when some async runs, it launches 2 parallel tasks. This is the first one. This is the second one, and basically they start after 1 second. Both of them end, and this thing produces the result, right? Then increment happens, and just what's changed gets re-evaluated. But ultimately, you see that like this, basically these 2 tasks, they run in parallel. So why we don't see something similar when we use just A here? Why we don't see get async of A and then a subsequent like plus get async of A? Well, the reason is if a computation of some compute method already runs for given set of arguments, then no way another similar, I mean another identical computation starts till the moment the first one completes. And the reason is like what would you expect by or like what's the benefit of running 2 get async of A in parallel? Ultimately, if one of them completes, then we can immediately return the same output from the second one, right? Because unless the first one is invalidated, it's a correct result. So that's the reason why they basically never run in parallel for the same set of arguments. And like in reality, there is an asynchronous lock based on the key of whatever is used in cache and or as caching key. So what else? I think honestly, yeah, that's it for the tutorial. There is a little bit different example on this concurrency behavior and concurrent evaluations in the tutorial, but you're welcome to try this one. And but it basically shows the same outcome. So let me think what else to show here. Well, I guess you might be curious what if we put what if we use A, B, and C here, right? And just for the sake of clarity. So for A, B, like 2 evaluations, right? And basically, I guess nothing unexpected so far, right? If we replace the increment for, let's say, C, then yeah, so it doesn't evaluate get async for A here because the value is still the same, right? So again, nothing unusual, and I recommend you to play with this. But overall, these services behave like basically the output of any method is cached, and everything that is computable is computed just once. So basically the re-evaluation of something happens only if something really changed. That's it for the part one, and I hope you will watch the second one and all the following ones. Thanks.